Hello, Mr. Betts here. I'd like to take a look at an example using a limit and evaluating a limit using the fundamental theorem of calculus. So if you remember, pretty much everything we've done in calculus is determined by limits. So we used limits and defined the derivative in terms of a limit. We've also defined an integral, a definite integral or an area in terms of a limit, so a limit on a Riemann sum. But there's also going to be limits that we're going to evaluate that look like this. So we have an integral within a limit. So this particular limit, if we try direct substitution first, if we look at what happens here in the numerator, I should put an x there. 1 to x of 1 over t dt. This limit right here is going to approach 0 because as x gets closer to 1, then the area that we're finding under the 1 over t graph is going to be just this line right here. So that limit is 0. And if we look at what happens in the denominator, if we just plug 1 in, we get 0. So since the limit in the numerator and the limit in the denominator are both 0, this is a L'Hopital's rule problem. And remember, L'Hopital's rule says we can evaluate this limit of an indeterminate form, which I've confirmed the indeterminate form with these limits. We want to make sure we do that. Then we can take the derivative of the numerator and we can take the derivative of the denominator. Well, now with the fundamental theorem of calculus, we know how to take the derivative of the numerator. So to take the derivative of this, we're essentially just going to take that x and plug it in for t. And so the derivative of that expression, that limit, or I'm sorry, that integral is just going to be 1 over x. And then in the denominator, we take the derivative and we get 3x squared. And we can try direct substitution again. Just kind of informally, we can see on top it's going to be 1 and on the bottom it's going to be 3. So we don't have to worry about doing what we did here earlier to show it's an indeterminate form, because it's not. And we just plug it in. So we get 1/3, and that is our answer. So notice that to do this, to get our answer here, we had to take the derivative of that to get that, which uses the first fundamental theorem of calculus.